somewhere at the equator, right, in Ecuador or something in South America or in Africa or wherever you please. That person is in the so-called, what you call a globe model, is traveling around, is moving in a circle around the axis around the center of the Earth at 1,000 miles per hour. As I prefer to use kilometers per second or kilometers per hour, but or meters per second. But okay, whatever the units you want to use, that the change in that velocity, in the vector velocity, because when you deal with forces and accelerations, you need to use vectors. So the change in that vector velocity is, in half a day, it changes. So in 12 hours, that velocity changes by twice, because it's 1,000 miles per hour in one direction at say noon, and then at midnight it's the same amount, but the other way around. So it's the vector change is twice that, and the person is standing perfectly still. So what is the force that caused that person? Does the person have to be aware of a force, of a terrible force that they have to apply on themselves in order to change from 1,000 miles per hour in one direction to 1,000 miles per hour in the opposite direction? So it changes by 2,000 in the space of 12 hours. That's a huge acceleration. How? Held by a child at the equator, right? And then yes, that balloon is spinning, is moving in this direction at 1,000 miles per hour at noon, and it's moving the other direction at midnight. After half a day, after 12 hours, it's going 1,000 miles per hour this direction. So the difference between this and this is 2,000 miles per hour in 12 hours. So that is a huge acceleration.
Why are we going the opposite direction?
What is the force? What is the force that has made the balloon change its velocity by that huge amount? It's 2,000 miles per hour's difference. It's twice the difference. No need to go to change latitude. You stay at the same latitude and wait half a day, and then you change your velocity is changed. Your velocity. Your velocity. The vector velocity has changed by twice the amount. How come? And that's stationary in respect to the Earth. That's a balloon. That's separate from the Earth. That's not the Earth. And what is dynamics for that?
What's your question now? Why is it stationary but supposedly going?
I'm saying that this balloon has one velocity here and one velocity there 12 hours later, and it's changed its velocity by 2,000 miles per hour. So
it seems stationary. But the point is that it seems stationary, but it's changed. It's changed 2,000 miles an hour, even though it seems completely stationary relative to the person with the balloon. Is that what you're saying?
Yes.